This presentation is about recent developments on thin film and short path evaporation and how this has been applied to several technologies. For the longest time, the industry has been using evaporation for many applications, but the principles of the technology have been basically the same for 100 years. And I, in my previous life, basically, all the way from grad school, where I did the work on thin film evaporation, actually, to today, where I will present, hopefully, some interesting data on a hybrid system, where we are combining several principles to achieve a better and more optimal evaporation, separation of contaminants, and so on, and how it applies to some lecithin processing, some phospholipid processing, and also some recoveries of bioactives and the removal of contaminants. So again, this is myself from Advanced Consultants, and my co-author is Rob Ranges from Artisan Industries, and I will, in 20 minutes, we'll try to describe some of the principles of this, what we consider new and exciting principles to process not just lecithins, but other bioactives in the lipid area. So I will start with what is thin. We usually think of thin film versus short path distillation, okay, or put them against each other. That doesn't have to be necessarily the case, but we will present a little bit on that. Then I will touch on how we have used these technologies to process lecithin, phospholipids, and phospholipid-based oils like krill oil. Krill oil is half phospholipids, basically, so it requires a specialized type of processing to purify it, to concentrate it, and so on. So our technology does that. I will talk about what are the principles involved in this, and also we are able to remove contaminants. So it can be a simultaneous process of purifying, removal of contaminants, and also concentration of some of these bioactives that I will get to in a minute. So. Then I will talk about how we are concentrating on omega-3s. This is another exciting area where the industry is very active right now, how to concentrate these pharmaceutical grade omega-3s. So then we will mention some conclusions on this. So thin film evaporation, basically, that's what it is. It's a system where a film falls on the wall of a hot plate, a high surface, and you have evaporation taking place as the film is heated through the plate. Then in short path distillation, you have the vapors generated from the thin film on the wall, and this thin film can be spread out, can be a falling film, and the evaporators generated. In the case of just thin film evaporation, the evaporators have to be exhausted into a vacuum system. In short path distillation, the vapors are immediately condensed into a cold surface. So that is the advantage of this. At the same time, generating further vacuum. So it is very advantageous. So that's why usually we put them one against the other. But in this case, you will see that we are able to combine the two principles and have some sort of hybrid system that becomes very efficient in removal of these contaminants and concentrating these bioactives. So I just wanted to mention a couple of basics on this. So basically, thin film evaporation involves heating something, transferring heat through a wall, and then you have mass being removed from the film, basically. Usually involves a heat being transferred on the heating area, usually steam. The heat being transferred by conduction through the heated surface, and then the heat transfer in the evaporation or evaporated surface. These are general equations, just to give you an idea of what we are talking about. And this, you can apply them to thin film evaporation. For short path distillation, we have a few more advantages going on. The general principle is, and the reason why it's called also molecular distillation, is as the molecules are evaporated, they follow a free path, basically. Okay? So it's a laminar flow that goes directly from the evaporating surface into the condensing surface. So it's a very efficient way of transferring mass and condensing it almost immediately after it's evaporated. So that is the advantage of short path distillation, basically. And this mean free path is, this is a quick question of that. It's fairly well understood. We understand why this mean path is having a laminar flow is so important to be condensed immediately, and instead of having to travel through all this piping system into the vacuum system, is condensed right away. So that gives us the basics for that, hopefully. So there is a lot more math, a lot more principles involved. We just don't have the time to deal with all of that. So, okay, so the advantages: very short residence time, very efficient mass transfer, like I just mentioned. These are laminar flows through these paths, and we have a very rapid condensation of steam in the internal. And this is what I need to emphasize. There is an internal condenser in the evaporator. Okay, and this is what this system that I'm describing is able to do. Usually, the molecular distillation unit will have these mechanically agitated systems, and whether it's for processing lecithin, whatever it is, scrape surface heat exchangers, and when you apply an internal condenser to that you have the short path distillation effect, basically. So, this condenser is usually in the center of the body of the system. So, the way we form the films, we spread them with rollers or wipers. In this case, you'll see that it's all by gravity. Well, we have two systems actually that I will describe in a minute. Some of them will have this dual purpose of being a thin film evaporator and also a short path distillation unit. So, the first advantage is that processing of lecithin, unfortunately we don't have the time to go through all the steps, but lecithin is obtained from the gums, from the degumming process of fats and oils, soybean, canola, sunflower. The first step is usually a degumming to remove the gums. Those gums are basically the lecithin that has to be evaporated, dried, purified, and so on. So that's what this machine does for us to drive the lecithin very efficiently. Removes also peroxide. This is the advantage. Like I said, it's a dual purpose: to dry, but also to refine and purify the lecithin as well. So here we have two systems. One is what we call the short path stripper. The short path stripper is basically a design of several internal stages. Usually a thin film evaporator will be one long stage. In this case, the design involves this series of internal plates inside the evaporator that allows us to create stages and allows us to have a more efficient, evaporation through these basically more theoretical plates. For those of you in engineering will understand what that means, having all of these phases generated. This is for larger volume processing. We also have the system of what we call the ROTOTHERM. This is an actual scrape surface evaporator. There is pallets that spread a film on the surface, on the heated surface, and produce this very efficient mass transfer. And it also does a very efficient job of drying lecithin in a single pass. So all of this later on I will explain further how we are talking about single pass. In many applications, short path distillation involves several passes to achieve the concentrations that we desire in products. So. And we can also get powder. Lecithin can be converted into a powder. So this efficient scrape surface heat exchanging system that we have is very important for that. Krill oil, very popular. The market for it has grown. Krill oil is basically a phospholipid-based oil. So when you think of krill oil, think of a phospholipid. 40%, 50% phospholipids in it. So just translate that to processing lecithin, basically. So we've been very successful to process that, and we remove peroxides as well, removes fatty acids. free fatty acids. So it refines the process. There are so many applications. We just don't have the time to describe all of them in detail. So it does purify. So we also remove contaminants. This is the general process to process refined bleach and deodorized oils. We don't need to go into the details for all of them, other than at some point, especially for fish oils, where you have to remove contaminants like dioxins, PCBs, brominated compounds. This is the part of this process where these machines, these short path strippers and ROTOTHERM system that I'm describing here, is replacing this part to remove all of these contaminants, basically. And the last step is usually deodorizing, which the stripper has some of that. For omega-3s, we also have this series of steps, and this is the step where our system, this short path stripper and this ROTOTHERM, this rotary scrape surface evaporation system that we have, is able to concentrate. Usually you can achieve 50% concentration by molecular distillation. In fact, when you purchase omega-3 concentrates, this is about the concentration that you found very conventionally using molecular distillation. So with our short path distillation system, we can achieve higher concentration. These are the other steps. We don't need to go into detail on that. We just don't have the time, and that's for another talk. So we can remove all kinds of contaminants with it. Basically, the advantage, like I said, is that this short path stripper is several internal stages that allows us to create several theoretical plates, thin film with an internal condenser. So you have a dual purpose going on here of having an internal condenser that removes the condensate right away without the vapors having to travel to the vacuum system and saving a tremendous amount of energy. So it removes very efficiently dioxins, MCPDs, and we have the data for that. So this is for the short path stripper. And we are able to mitigate, right now MCPDs are of great concern, especially for palm oil. So this system, we have proven that it can do that. So, and this is some data for some levels, lowering the glycidyl esters and the MCPDs very efficiently to regulatory levels that are required. So also using this SPS stands for short path stripper. Is the name of this, like I said, series of internal steps with an internal condensation that allows us to do this, basically. And it, at the same time as it removes these contaminants, is able to deodorize and purify and physically refine the oil. So that's the other advantage that we have in this. So there are no internal moving parts. So we can make them as big as we want for larger capacity. So, and as much vacuum as we want to input in there. So very efficient way to process this. And these are just some examples of how we remove these what we call high boilers, basically higher boiling contaminants. Concentration of omega-3s. This is another very active area in short path distillation of molecular distillation, and we are able to use this combined system of thin film evaporation and short path distillation of molecular distillation in a system that will have an internal condenser with no moving parts. So it's a hybrid, very efficient system, and we are able to concentrate these omega-3s. Usually a molecular distillation system will concentrate up to 50% EPA and DHA, and we are able to achieve in one pass up to 71% right now. So this can be further optimized. So that's the advantage of having so many internal theoretical plates in the system and having an internal condensation system. So those two are great advantages that is a great development for this system. So, and we are able to, because you can regulate residence time, you can regulate feed rates and so on. So you can play around what you want to concentrate more, EPA or DHA. So, and this is really some numbers of what we are talking about. We can achieve up to close to 70% basically in one pass. this can be further optimized to achieve higher concentrations for this system. So that's sorry. A quick rundown on this is a lot of ideas. The main idea stays though. That is a hybrid system that allows us to concentrate, to refine, to remove impurities with this. And this is, like I said, for smaller volumes, relatively smaller volumes, we do have a horizontal scrape surface, short path distillation system that we have the advantage of being able to regulate residence time. We can adapt rectification towers, so we can play around with the concentrations, and we have the short path stripper that is for larger, if that's what we want to do, larger volumes with internal condensation and as many theoretical plates as necessary for us to achieve our objectives, basically. So we can refine very efficiently, process krill oil and lecithin products. We are able to mitigate all of these oils with contaminants such as dioxins and MCPDs and GEs, and also one of the later great applications of this, we are able to concentrate omega-3s in one pass. Again, you can do several passes if that's what is necessary, but that's what the industry does with regular molecular distillation. But with this system, because we can design it with as many theoretical plates as necessary, we can achieve this level of concentration. So if Artisan has a booth in the meeting, if you want more details, in 15-20 minutes, it's impossible to give you all the data that you would be interested on. But I hope we gave you at least an idea of what this it's really innovative. For those of us that have been in the industry dealing with falling film evaporators on one side of the plant with molecular distillation units on the other side, now you can combine these two principles and come up with all of these improvements. So that's really all I have for you right now. So any questions? Any comments?